It really does.
All right, so we're going to go on to this section of real zeros of the polynomial functions.
Yeah, that's a waste of time.
Yeah, but it's
Okay. So the idea is we want to find out where these graphs, where these functions cross the x-axis. Where are the value of the function 0? Okay? That's the idea of a real zero of a polynomial function.
Yeah.
So if f of x and d of x, now notice the functions they pick. Okay? F of x is what we're starting with. That's the function we're going to start with. And d of x are polynomials. Well, they use the d because d is going to be the divisor. That's what we're going to divide our polynomial by. That's why they use d of x. And that's why they picked that, because that's the divisor. And they are polynomials such that d of x, the divisor, does not equal 0 because you can't divide by 0.
Yeah.
And the degree of the divisor, d of x, is less than or equal to the degree of f of x. There exists a unique polynomials, q of x. What do you think q stands for? Quotient, because when you divide something by a divisor, you get a quotient. And when it doesn't go in evenly, what do you have left?
Remainder.
A remainder. Remember from long division, you used to write plus R3. Isn't that what you did in 4th grade or 5th grade, whenever they taught you that?
Yeah,
You divide something, it didn't go evenly, they'd write R something. Isn't that's what we did in like 3rd grade.
Ben went to Montrose.
Until all of a sudden they
Hey!
skipped a lesson, and then they're like, yeah, just kidding, remainders go in as a decimal.
Okay. Well, before we did decimals, I remember in grade school, I don't remember the
Yeah, I
grade,
know,
but I remember we had to write a big R and tell what the remainder was. But that's all this is.
Yeah.
So this is our remainder. So that's all those letters are. So I think these letters, you read these blue boxes, which are the most important things in your book, and you see something like this, and you think, well, what is all that? And you get confused, and then you get frustrated. Well, they just pick letters that make sense. So if you take your divisor and multiply by your quotient and add your remainder, that gives you your original polynomial. Okay? Put it in simple terms. We have, how would you do it when you were in 3rd grade? You said 8 divided by 3, and then you would have your quotient up at the top. So you'd have a 2, and then you got the 6, and then you subtracted, and then you had 2, and before you knew how to do decimals, you do it like that, right? You do 2R2, 2 remainder 2. That's what you would write, right? In 2nd grade or 3rd grade, whenever they taught you that. So what is that saying? My original 8 is equal to my divisor times my quotient, which was 2, plus the remainder of 2. 3 times 2 is 6, plus 2 is 8. That's all that the division algorithm is. Okay? Where r of x is 0, that means where there is no remainder, if my r of x is 0, then it went in evenly. Or the degree of r of x is less than the degree of d of x. If the remainder of r of x is 0, then the original polynomial, d of x, divides evenly into f of x, our original polynomial. So basically, when the remainder is 0, it divides evenly. It's all the same. All right, so let's do one of these. Because you want to do one of these.
No.
Okay. All right. So we have this. We have 5x squared minus 17x minus 12. And we're dividing by x minus 4. Now notice something that I forgot to highlight up here. And, I might not have written that down there. Okay, well, I didn't write it up on my board, which is fine, but I'm going to tell you something. So this works when the divisor, d of x, is in the form of x minus k. Or it's got to be a subtraction function.
The remainders here.
Is it on the next page? Let me just
Yeah.
go ahead. Okay. So when we're dividing these polynomials, it's important to note that
There's the remainders here and the factors here.
well, no, I'm just on the division algorithm.
Yeah, but I mean, like,
I'm just saying.
x minus k or whatever is one of the.
Okay. Well, when we're going to do this, you have to make it as a subtraction. So that's all I'm saying. So what this has to be is has to be in this form. So if this was x plus 4, I would have to change that to x minus 4. If it was x plus 4. I'd have to change it. Because you can only do it as a subtraction over here for your divisor. Your divisor has to be a subtraction. Okay? That's all. All right. But that wasn't But this one doesn't apply to that anyway because it's not minus. But I just wanted to make sure I pointed that out before you did it and then didn't change it. Okay.
Why'd you undo it?
Why did I undo what? Because this is already a minus, so it's already x minus 4. Okay, so when we're dividing these things, oh, I see. Yeah, that's more important when you're doing the synthetic. I see why they didn't put it till the next section. All right. Anyway, so when we're dividing our polynomial, we're dividing it by x minus 4. You're going to do it just the way you did long division. Well, how many times does x go into 5x squared?
5.
How many times?
Don't know.
How many times? If you divided 5x squared by x, what would you have left?
What do you mean?
Oh.
5x.
5x.
Oh.
Right? If you take an x out of 5x, or 5x squared, you just have 5x left. That's all. Now, what would you do when you did long division? What did you do once you put your number up there?
You put it.
You multiplied, right?
Yeah.
All right. What's 5x times x minus 4? Is
No,
what?
No. Times x minus 4. 5x squared.
5x squared
Minus 20x.
minus 20x. And then what did you do when you did long division? Once you got to this point, what did you do? You subtracted. So guess what? If I subtract, that means I'm changing that sign, right? Subtract and multiplying the whole thing by
Oh.
minus, right?
No wonder I never understood this.
3x
You're just
minus
subtracting.
12.
5x squared minus 5x squared is 0. That cancels out. 17x plus 20x.
3x
3x.
minus 12.
Minus
Who
12.
taught you how to divide in elementary school?
Mrs. Berger.
Mrs. Brewer.
Okay.
But I was sick, and then she never taught it to me ever
Actually,
again.
Mrs. Thorne taught me.
Well, I'm teaching you now in 11th and 12th grade. So.
Well, I mean,
Just checking, I just.
How many times does x go into 3x now?
3.
What's 3 times x minus 4?
3x minus 12. But, yeah.
3x
Keep going.
minus
I'm like
12.
this. You gotta subtract it. Oh.
oh, it's a 0. There's no remainder.
What does that tell us?
5x plus 3 is the...
Is a factor of that long polynomial. So 5x squared minus 17x minus 12 can factor into 5x plus 3
Oh.
times what? Now you
X minus 4.
now it's easy to figure it out. X minus
Oh!
4. This is your divisor.
I never thought I'd have to use long division again.
It all comes back. So you see that the divisor is one of your factors. Your quotient's one of the factors. If I multiply my quotient times my divisor, I get my and add my remainder, which is 0. I get my original polynomial. That's the division algorithm.
This makes sense.
Glad, very glad. All right, let's see.
Are you,
I want you to come up now, Ben.
What?
Yeah.
No.
Here you go. Yeah.
No.
Oh, you get to use this
Come on, yeah, it's fun.
whiteboard.
It'll be the most fun you ever had in your life.
No.
You come and divide that thing for me.
Are you sure you want me to do that?
Yeah, I use my
Are you
hand now because I
sure?
found that my finger works better than that stylus. So either way, I'm gonna set that up.
2. Oh, no, I'll have enough room. Whoa, this feels so cool. Kelly, you gotta try this.
Okay.
Oh, look, you're doing math. Don't look now, Mom. Where's the yearbook photos?
I used to love math, but then I got to geometry. Sorry, Miss
Yeah, that
Lucas.
it all went downhill from there.
It did. I loved Algebra 1.
I didn't because I taught myself, but
Oh, you'd Mrs. Arrow? Yeah.
Just be careful. It's not a square root, but you're.
No, it's not.
I know. I know.
It's not.
I know you know it's not. That's all right.
I'm not hitting undo either.
Well, that does that to me all the time. I get extra lines.
Hey! No picks.
All right. So now what?
You want to get rid of that,
Good.
so you multiply it by 2x squared.
Very good.
Plus. Hey!
Ah, I got
Right.
videos, I got pictures for the yearbook.
So minus. So that'll
Put them
turn
on
you
your
to
senior
a
page.
big
Look, Ben
minus.
can do math.
So 2x. Am I doing this?
So far,
right?
you're perfect. I haven't seen any mistakes yet.
Alright.
Look at
It's still early.
that. Okay.
Uh,
Very good.
it's minus. So, once again, minus, cancels. Ooh, negative 32.
Yeah.
Okay. Am I? No,
Doing fine.
I don't feel like I am.
You are.
Do I need a remainder? Or do I
Well,
have
first
to-
you got to get rid of that 32, right? Don't worry
Yeah.
about a remainder.
Yeah.
Just keep dividing.
Oh.
No.
What?
Well, you got a minus and a plus. You're gonna have to subtract it, right? To get that one. So when you multiply it out, you're gonna need a subtraction there, right?
Oh yeah, minus 32. So. Negative.
32x, right?
Oh.
Checking. Okay.
No, that's not good. I wrote a 6.
Just cross it off. It's fine. 32 times 6. What's 30 times 6?
180.
What's 6 times 2?
12.
180 and 12.
202.
No,
No,
180
not
and 12.
192.
Okay. Minus 192. Good.
Okay, so this will turn to plus. That'll turn to plus.
Yeah.
199 is your remainder.
Okay. And what did you do when you, now, after you got out of, I'll take the thing back and go to see. Good job.
Yeah.
So after you got out of grade school, when you no longer could write the R, how did you write your, well, you probably did them next to the decimal, but now we don't do decimals because we want a fraction. So my answer is going to be 2x squared plus 2x minus 32 plus my remainder. What's my remainder?
199.
Over what?
Something.
Over my divisor, right?
Oh.
199
I think that'll be enough.
over x plus
Oh, yeah.
6.
Okay, I paid for that.
That's the answer. Does that make
Isn't that
sense?
a questionnaire that
Your remainder over your divisor.
anybody else-
Because you have a remainder, that tells you that this is not a factor of that. It won't go in evenly. So that's not a factor of that. Okay?
Yeah, that makes sense.
All right, so far we're good?
Dogs that were fighting
For the most part.
Outstanding.
and one of their teeth hit me.
All right.
They would bite each other and separate
All right.
them.
This process is called long division of polynomials. That's all we did. In the division algorithm, the rational expression, f of x, our polynomial, divided by our divisor, is improper because the degree of f of x is greater than or equal to the degree of d of x. Okay? What does that mean?
If you want to type that up,
Because this
you can just write it up.
This whole thing was 5x squared minus 17x minus 12. And when it says divided by, it was over x minus 4, right? Because that's how we write division. So this is improper because the top, the polynomial, is a degree higher than or equal to this degree. Okay? This is a second degree polynomial on the top.
Yeah.
This is a first degree polynomial on the bottom. Because you have a second degree on top of a first degree, that's improper. That's why we're doing the long division. Same thing with this one. What do we have? What degree is this one? This polynomial here, the 2x cubed plus 14x squared minus 12x. What degree is that? I'm sorry? Third degree divided by first degree. It's improper. That's why we're dividing it. You can't leave them like that. Okay. That's all that's saying when it comes to that next screen that says it's improper. On the other hand, the rational expression r of x over d of x is proper because the degree is less than the degree of the divisor. Okay? What's that saying? This fraction here is proper because what's the degree of 199?
Nothing.
0. 0 degree. What's this? So because this is less than this, that's proper. Okay? That's all there is. That's all that's saying. So sometimes you gotta read between the lines when you're reading all this stuff and try to figure out what are they really trying to say to you. That's all they're saying. Was there? Oh yes. Synthetic division of a cubic polynomial. Well, synthetic division is really the same as what it's doing is it's allowing you to do the division of polynomials, only instead of doing a longhand like you just did, Ben, it's showing how can we do it quicker. How can we divide those and find out, what we have quicker. And there's a vertical pattern. K is our, if you divide this polynomial by x minus k, and this is where it was important that be a subtraction when you're doing the synthetic division. Use the following pattern. Well, for the vertical pattern, we add the terms up. So these are the different terms in our polynomial. In other words, these are the coefficients in front, A, B, C, D. So what's in front of our cubic, our quadratic, our linear, and our constant function. These are the coefficients, or what's going down here. What we're dividing by is our k. That goes here. Okay? And then what you do is you multiply these. So the diagonal pattern is multiply by k. So you're going to multiply k times a gives you ka. Let's do it in a real one because those letters are going to confuse you. I already know that. So let's do it like this. So how are we going to set this up? All right. What are our coefficients? What's going to go on the... What are our coefficients in our polynomial? What is a coefficient?
5, 18, 7.
They're the numbers that go in front of your variables. 5, 18, 7, and minus 6. Those are our coefficients. We have to list our coefficients. And we have to do them in order. It's got to be a proper polynomial, so it's got to be in order of descending degrees. And notice that I didn't skip any. There's 3, 2, 1, and this has a coefficient of 0. X to the 0 is 1, which is our constant function, right? What about this one here now? What do we do for our divisor? What's our k? What are we going to divide by? What is that?
3.
Remember that it's got to be in the form x minus k. So x plus 3 is going to be x minus 3. So what's my k? Minus 3.
Wait, so if it wasn't in that, if it was x minus 3, would it still
It
be
would just,
minus 3?
no, it would just be 3. Because it's just wants your
Oh,
k
it's
back.
that confusing
They
stupid
start
stuff
off
again.
January.
All right? All right. 5 times 3 is, 5 times negative 3 is what?
Negative 15.
Okay. And negative 15 minus, 18 minus 15 is, what's 3 times negative 3?
-9.
I'm sorry?
-9.
Okay. By the way, our 5 there was nothing to multiply. The first one just comes down. So 3 times negative 3 is negative 9. What does that leave us?
Negative 2.
Negative 9 plus 7, negative 2. Negative 3 times negative 2,
6.
6. And 6 minus 6? 0. What does that tell me?
5.
What do all those numbers at the bottom mean?
5x cubed, no,
5x
squared,
squared
plus 3x minus 2 with no remainder.
Correct. This, and then what was my divisor? X plus 3. Those go in evenly. So those, if I put them next to each other and factor them up, would come up to that.
So this is just another way of doing that.
Right, it does it without doing all that long division, so you don't have to keep writing them down. It just uses the coefficients.
That was more fun.
Well, you need to know both ways, but if you want on the test, it'll take you a little longer. Does that make sense? All right, Kelly, it's your turn to come on up to the board.
Okay, so I don't
You can do
understand
this.
what's happening right now.
You can do
Did
this.
you have a question on this one of what we did?
No,
Here's the
I
multiplying.
don't know. Okay.
You can do it, Kelly. I believe.
This one's a little trickier. I'll give you a hint, but that's all right.
No.
You can either. Here you go. Here's the little stylus.
Stylus. It feels so cool when you write it.
Okay. So it's the coefficients?
It is. In descending order. So this is a little tricky, so just take your time.
Wait, descending order?
Well, you notice how you have your cubic first, that's all. Good. Hang on.
What?
It's all right.
0,
What?
isn't it?
Oh.
Because you don't have a cubic or a quadratic, right? Good.
Wait, I was right?
Yeah.
Really?
Really?
Yeah, you can't skip any of your
Oh.
in descending order. That's why I was saying you have to set your polynomial
Oh.
-2. Good.
I multiply it first?
You do. You multiply those and it goes down under there.
What? Oh.
Remember your
See?
5 here comes down. Your 5 just comes down.
Oh, okay.
Yeah. You can write the 5 in. It just comes straight down. There you go.
So this is minus 10 under here,
It is.
which is just minus 10.
It is.
And then under 2 times 10.
-2 times -10.
And I subtract it,
You do.
is negative 14.
You add them. So you,
Oh.
you got you only subtracted here because you had a negative. These are plus and plus.
Oh, so it's.
That's right. Use the sign that you have.
26.
Yes.
And 2 times 26. And
26 is half a deck of cards. Times 2 is what?
Negative 52.
what? Minus 52?
I was just saying you can multiply 26 and 2
I don't-
quickly because 52 is a deck of cards, half a deck is 26.
I don't know how many. I didn't know how many that was.
Yeah.
Okay.
So 8 minus 52. Or, wait, yeah. Is negative 40?
4.
Good. -44. Outstanding. Have a seat. You're good. So what does all that tell us?
See, I don't get this.
Well, you got it. You got all the way to the end. Now we just translate it into what it means. So what does that mean? So what are these numbers at the bottom? What are they going to give me?
5x
5x what?
squared.
No.
Yes. Keep going.
Minus 10x plus 26.
And what's this? What is this one here? That's my remainder. Minus 44 over what?
X plus 2.
2.
Oh.
That's all there is to it. The part that will confuse you, that you'll have to remember, is there'll be lots of times that they don't put a cubic in, or I keep saying cubic, quadratic in, so you won't have a second degree variable in there. You'll have to make sure you remember to put the 0, because inevitably you'll do these and you'll go 5, 6, 8, and then it won't work out. So you got to remember that. And the other tricky thing is you always have to remember it's got to be in the minus k form. So you got to remember the number that you're using in the synthetic division. But if you remember those two things, the rest is really just multiplying. That's all there is to it. This synthetic division thing. Okay. When you're doing your homework, if you get confused, on the website, Ms. Mivius has a division. I think has on top of this one that'll be up. There's a Khan Academy one on synthetic division where they do 7 or 8 different examples, and you get more practice that way. So that's that one. The remainder theorem. Did I not save? Oh dear.
Didn't you not?
Oh, I did. I saved it on my